Again, my name is Craig Gardner, and I am an employee at SUSE, and I have sometimes played a role of pretending to be a security expert. But I've spent many years conversing with a variety of people who are certifiably experts in the field, and I've spent many times giving this exact presentation, only longer, that I've tried to make shorter for this presentation. And one of the most interesting things is, of all the things that I give presentations on, I'm asked to give this one the most. Even of all of my Red Hat and Ubuntu friends, they're always saying, oh, come to our user group and give us that presentation on hardening and securing your system. So I'll try to get through this as well as I can. Oh, I've got that nice 2 up in the corner, but we'll live with that. What I want to do today first is talk about what and why about hardening, some new recent details about hardening with newer distributions, just to talk a little bit about architecture and what is down in the heart of what it means to be a secure system on a network that is inherently people always trying to attack you, and some of the tools that will be available for you. So what should security be? Well, my good friend Roman Drahtmüller, whom many of you know, he says that good software does what you expect it to do and does it well. Secure software does exactly that, but nothing else. And that makes sense as you think about it, but is not instinctive to enough people. So as you talk about the kinds of things that are involved in having secure software, you have a variety of things that make things challenging for you to keep it secure. And you're always going to have bugs, and you're going to have crashes and things that are going to cause your system to go down, which are causing all sorts of headaches for your organization. But the one that causes the most trouble in terms of security is when you're talking about the security vulnerabilities, all those things that happen in the software that cause the software to behave in a way that it was not designed to do, to give access to people who were not intended to have access. And that often can result in data loss or theft, abuse of the system, and privilege transitions. One of the best things that I can do, and if I communicate nothing else to this quorum of people here today, one of the best ways to address security vulnerabilities and these other challenges with software is to keep it up to date. Now, to a body of people who run proprietary software, run proprietary operating systems, they reject this a little bit. They rebuff against this. But in this group of open source aficionados, we understand this, and we latch on to this very strongly. Now, to constantly be able to apply security updates, there are 2 concerns. Number one, in the business that you work, sometimes your business operation does not allow you to apply updates in a timely fashion. You might only have these small windows of opportunities to be able to apply your security updates. And that requires some convincing of your management organization that at least let me apply the security updates. I can wait until some other window 9 months from now to apply other kinds of software updates to fix other bugs. But let me apply my security updates in a frequent and out-of-band style. Another thing that comes up when you're talking about these kinds of things is the skepticism that some people have about open source software. They think, well, if I'm applying the latest updates, what's to keep me from introducing new bugs and new vulnerabilities with that latest update? At least I know the devil that I have today, and I don't know the devil that I'm going to have tomorrow. And yes, even though we advocate in an open source manner that there are more eyes and more caring, passionate people that are available to look over these changes that are taking place, you don't have to look very far to think about the things that have happened recently that have been around as vulnerabilities for a long time. We just didn't know it, like shell shock and poodle. But statistics tell us that better to keep your system up to date with the latest security updates than to continue to be exposed to those ones that have been around for a while. Keep your system up to date. There are a lot of ways that we can look at hardening a secure system, make your system more secure, but we're going to focus on this bottom one right here in terms of that deployment and installation and configuration phase of your system. And so when you're talking about the kinds of things that are relatively new in terms of these security capabilities, note that we have the bootloader security, which is a pain to us in a lot of different ways, but it does provide, by intent and in practice, a greater sense of security for systems that are available on your public network. Another thing that you may not like very much, but that does provide a variety of new capabilities to keep your system secure, is SystemV. As we mentioned previously, the more quickly that the distribution responds to security vulnerabilities and provides you fixes, and the speed with which you as the user are able to apply those security vulnerabilities is better today than it has ever been. SUSE in particular, we do a great job of having this very narrow window of vulnerabilities published and having patches available. But our other Linux friends are also very aware of this, and those distributions are constantly aware of getting those patches out as quickly as possible too. And then anytime that you can have the ability to apply security patches without having to reboot is a wonderful thing for your organization. And so these mechanisms that allow you to do that, like kernel live patching, extraordinary mechanism that's available to us. And it's also important for us to understand that it's not really always about what's the latest and greatest way to address vulnerabilities, or what's the latest and greatest technology, or what's the latest and greatest tool that you can do these things. What matters most is that you know how to properly use the tools that you have, and you have skilled people involved in doing this that are caring, passionate, and smart. One thing that I advocate that you do, without going into a whole lot of detail about this graph here, is set up in your environment a playground where you can put your new servers in and test them for security vulnerabilities before you put them out into production, out available on your DMZ. If you have a playground where you can test it and break it first and know what it is that you want to do with it, you are far ahead of the game. Once you've put it in that test environment and you've played with it in the ways that I'm going to recommend here in a minute, and you realize that yes, this system is going to do what I want it to do and only what I want it to do, not anything else, then you put it out into production. A few screenshots. Now these, like I say, I used this presentation in a variety of different settings. These are SLES slides, but the principles apply. It's the principles that we're talking about. It doesn't matter what distribution that you're using. It doesn't even matter that you're using Linux. These are the principles that we're talking about that make this more secure in your environment as you harden it. As you go through this first process here for SUSE Linux Enterprise Server, the reason that this is important is that you're going to set up the mechanism whereby you're going to get the latest updates for all of the software. So for SLES, it's this registration mechanism, maybe different for whatever distribution that you're using. And OpenSUSE is similar but not the same as you have here. And then of course another important thing that you're going to worry about when you're hardening the system, configuring and installing this system, are the network settings. So we'll go into the network settings here, and this is a little bit hard to see, it's a little bit too small, but you can see that you have a variety. Let's see, where's the stuff that I'm looking for on this particular screen? I updated these slides, and so I'm not as well versed on this, but you've got this where you're going to enable the card, and in this case you're going to be setting up the IP address to be assigned by DHCP. Things that are going through your mind about setting up the network card. I switch over here to the host name settings, and you have these two selection switches here. To change the host name via DHCP, there are some opportunities to attack a system when you can attack, when a service relies on a host name and the host name of that server can be changed by DHCP. If I can compromise the DHCP system, I now have a mechanism to attack the servers within that system. So be aware that changing a host name via DHCP is probably not a good idea for externally available services. Other kinds of things that you would consider on this particular screen, note that this site designation is now no longer valid. Some changes to our standards in DNS make this a problem, but that's not necessarily a security problem. Then creating users. This is very important. This is very interesting. And this is, of course, the kind of thing that people are always thinking about in terms of security and hardening, but not necessarily in the way that they should be. Yes, they're thinking about passwords, and yes, they should be thinking about root privileged passwords that are secure and not using the same root password for every server. Those things become pretty obviously to most system administrators. But another thing to consider also is what kind of strength of password that you have. In this particular case, this is demonstrating that the password encryption method is going to be SHA-512, which is state of the art. That is really the best recommendation that we can give today. You can do much better, but we're content that you've got the compromise of efficiency and speed with the type of encryption that you have with 512. And then you might look at something like this and drill down into, certainly you don't want to automatic login, right? Maybe for your laptop, and certainly not for me. I would never auto log in on any system. But on a system that's on your public network that's providing a service for your customers, there's no way you want to enable automatic login. One more thing here about passwords. Drill down in here. You notice that there are still a variety of password encryption types that are available, including DES. DES? Are you kidding me? Why do you think that we still allow the system administrator to use DES? Yes? Yes, absolutely. For example, if you've got any Sun systems in your network and you're running NIS, YP, you still have to use DES to be able to do that kind of infrastructure-wide communication. So there are reasons to have this, but if you can get away with not having those less secure encryption algorithms, you'd be very happy to stay with SHA-512. Other kinds of things, yes, the root password, we just talked about that. Don't use the same root password on all of your systems, and try to use a secure one, which is a whole different discussion that we don't have time to talk about today. Interesting recent research about passwords, though. We talk about passwords in terms of using special characters and mixed case alpha characters, and certainly incorporating numbers. But the research today still suggests that the best passwords are nonsensical passphrases, a series of words concatenated together that don't have any logical relationship to each other. Something that's still easy for you to remember, but that would be difficult to be hacked. Installation settings. Tafur gave some really great optimization recommendations a couple of sessions ago when he was talking about optimization and performance for Linux. This is security optimizations that we're talking about here. One of the things that he recommended is make sure that you only install the software that you intend to provide as a service on your system. If it's going to be a web server, install Apache or Lite or Nginx. If it's not going to provide any web services, don't install a web server. Far more secure to not even have the software installed. And you have to be aware as well of what kinds of other software that you're installing that could, by dependency, drag in services that you're not 100% aware of. Package managers are terribly convenient when installing all of the dependencies, but a little bit does you a disservice because they could be pulling in software as dependencies that you didn't even know that were being installed. Pay attention to what packages are being installed and make sure you're only installing the software that you intend to run. Other kinds of things, whether or not you turn on SSH, there are lots of various different ways to administer a box than SSH. It's very convenient, but if you can get away with doing other kinds of administrative things without SSH, don't install it, don't enable it, don't turn it on. One more thing about firewall, and this is somewhat of a radical recommendation that I give you here. But this is something that Roman Drachtmüller and I would talk about quite a lot. NetFilter is a great invention and has provided a great deal of security, peace of mind, I guess is what I really should say, about what's going on your system and what's not going on, and a great logging facility for those kinds of things. But when you get right down to it, as long as you only have those things listening for services on the box that you intend to be listening and providing service, and nothing else is turned on and nothing else is listening, your box is just as secure as if you were running NetFilter. You might want to consider just running those services and turn the net filter off and get some benefit, some performance benefit out of that. Now, that's too radical for some people, and that's fine. Use net filter, it's a great thing. Consider what the alternative is and how secure you can keep the box without it. You might be interested in seeing what you can accomplish that way. Let's see, what other things should we talk about here? Oh, one more thing about booting. It's very nice that grub allows us to put a password on the bootloader. Boy, that's really inconvenient. But that is a feature that you have to be able to keep your system more secure. So you go down to the bootloader settings, and let's see, is there anything else on here on the screen? Booting from the root partition versus booting from the master boot record MBR. It's mostly a wash. In terms of security, one's about the same as the other. But then moving over here to the bootloader options that we have here, you can now put in a password. Protect the bootloader with a password. So grub is very nice to allow you to do those kinds of things. Again, not terribly convenient. Every time you boot, you have to provide a password, but can provide for you some significant security advantages. And then here you go through the installation process. Pay attention to what got installed and what didn't get installed. Make sure you're only installing those packages that you intend to use. Good. Now, once the system is installed, and I'm talking very fast, I'm sorry, some things that you will consider to harden the system after the installation. So now we're going to do some configuration. First, we start with the network settings. We did a little bit of the network settings before. We can do the same sort of thing here, bring up the DHCP enabled card and switch over to the host name such, and we can not have this change host name via DHCP thing checked. So that's good. That's all the same sort of thing. And then you have this is Wicked, which is a SUSE Linux enterprise feature, but the same sorts of options exist no matter what operating system that you're using. If you're not going to be using IPv6, turn it off. And as a matter of fact, some of the biggest challenges that we have about securing and hardening a system is the physical access to the ports. You might also consider physically disabling those ports that you're not going to use. Because if I ever get physical access to the server and I can plug it in and maybe it's DHCP enabled, I now have some kind of way to hack the system. So turn off ports that you're not going to use and turn off protocols that you're not going to use. Of course, if you're going to use v6, use it. Let's see. Now, one of the great things that is a feature of the SUSE environment that's not available in other environments, and I keep pestering my Red Hat colleagues and my Ubuntu colleagues saying, you need to get up to speed and be good like SUSE and have what we call the security center and hardening. And in here, you have this fleet of settings that SUSE is informing you and coaching you as to what could be set or unset that will make your system more secure and tell you why it thinks it's not so secure with the settings that you've selected. You have a columnar, a set of columns, a table view here where you can see, for example, the use magic sysrec keys in this column here. And then this tells you the status is unknown. It doesn't know what the state of that is, and then gives you a security status, whether it's secure. This is an X mark here. And then, for example, down here, disable remote access to the X server. That's with a check mark because it's disabled. These are the recommended security settings for each of these different things. Can you think of a reason why you might want to disable sysrec keys from a security perspective? If I get access to this virtually or physically and I can press that sequence of keys, I now have a vast amount of information and a certain amount of control to that system. So although for debugging purposes, the magic sysrec keys are extraordinarily valuable, in a production environment, I don't want those enabled. Make sure you disable those things to reduce that security vulnerability. So all of these different settings and the status as the security center is detecting it and the recommended setting for it. Great thing, and there are nearly 100 of these kinds of settings with recommendations, including help value. There's a description button. You highlight any of these things here, it'll tell you the the description of what that thing means and why there's a security implication and what the recommended setting is for it to make it more secure. So quickly about architecture and design, let me check what the time is before I get too carried away with this and know how much faster I need to talk. One of the nice things about the Linux kernel is it's certainly not a silver bullet or a golden hammer. It doesn't solve all of our problems. But it's been designed very nicely, as best we can, constantly making improvements to protect that kernel land with a well-defined set of APIs where user space can access those kernel features. It's a very nice design that helps to keep the system secure. It's not impenetrable, but it works fairly well. As from a hacking perspective, from a system administrator perspective, you'll want to always be considering, always be thinking about how the system might be compromised by someone who wants to hack it. And so you have to kind of think like a hacker. How does a hacker think about compromising a vulnerable system? Hackers are generally lazy. They're going to try the easiest things that they can first, and then depending on how important it is, or how much valor there is in conquering a system, then they'll try a little bit harder and a little bit harder and a little bit harder. But if you get rid of the lower lying fruit and make it not worth their time, discourage them as early as possible, the less likely it is that they'll compromise your system. So you go from the outside in, starting with the network layer and then going down into the kernel layer. As far as the network is concerned, you have a variety of things that you're thinking about. We mentioned disabling the interfaces. If you're going to use it, absolutely keep it enabled. But if it's not, turn it off. Disconnect the cable, seal that avenue off. You want to make sure that you're thinking about whether or not the system is supposed to be doing IP forwarding. Vast majority of systems shouldn't be doing IP forwarding. If you're not intending to be forwarding, turn it off. You heard my recommendation about NetFilter. It's a good thing. I'm not saying NetFilter is bad. Just consider what's going on, and we'll get more into that as we go on here. You might keep a periodic record snapshot of what's in your ARP table so that you know what systems are actually connected to your box, and comparing that from time to time. What's in my ARP table today versus what was there a week ago? Hey, there's this new system. Do I know what that system is? Should that system be connected to mine? Good way of monitoring what kinds of systems are attaching to yours. And a variety of other things that we don't have time to delve into. The next one is the port layer here. It's a great idea, in addition to this idea of turning off the NetFilter. Do a port scan from outside and see what ports are open. And then compare that to what it is that you intend to have running from the inside point of view. And if there are any discrepancies between what you get from NetStat and what you get from Nmap, then you need to figure out what those are. Once you know what it is that your box is serving, what you intend to from the inside and what's actually being advertised on the outside, and you're happy with that, there might not be a need for you to actually be running a NetFilter. And always don't lose sight of UDP. Sometimes it's too easy to overlook UDP. Now, the next layer, services. Disable all the services that you don't need. And by that, the best thing to do is just don't install, remove packages from the system that you're not going to use. If the software is not installed, then that's certainly not going to be listening on that particular port. It's not going to be providing that service. Remove the run level symlinks. Of course, I should need to update this to be SystemD. I'm sorry, I keep forgetting to do that. I need SystemD syntax for this instead of SysV. Kill the services that are running. Don't take for granted that doing this stop mechanism is going to actually do it. Once you've done it, look at the process list and see that it actually is not running anymore, Apache in this case, because sometimes you can be deceived by the init system telling you that it stopped and it really didn't. Next thing, at a process level, have an understanding of what's actually supposed to be running on the system. Know what all of those processes are. Every good sysadmin will be able to look through there and see, oh yeah, there's the name service cache daemon right there. I know that that's supposed to be running. And if you don't know what it is, then you can use RPM to kind of tell you what it is. Or of course you can Google and figure out those kinds of things. Deactivate those things that if you don't know what it is, sometimes that's inconvenient to people. If people are using the service that's running on there and you don't know what it is and you get panicky and you kill the service or you kill the process ID, and then they come running into your office and say, what happened? I was using that. But that's always an effective way to find out who's using it. It's not the best way to do it, but that is an effective way to find out how critical services are. All right, so next one is files at a file system level. And RPM does a great job of helping us to see what kinds of things are installed and understand what things are installed on the system that aren't controlled by RPM. That's also good to know. You have in SUSE Linux this check stat mechanism to go through and figure out what's got which permissions, right? You want to know what kinds of things have an SUID of 7 and that have elevated privileges. And being able to reconcile that and reset those files that shouldn't have those kinds of permissions. And then there's the advanced intrusion detection systems that you can look at to see what's actually installed on the system and keeping track of those files off box so that you can make it a comparison. Last week that software wasn't installed and it's installed this week. Why is that that software installed today? At a kernel level, it's nice to have those mandatory access controls available to you, and AppArmor is an excellent way of doing that. And here's an example of a rule for the, what do I have, the DHCP the daemon, DHCP daemon. That makes sure that it's confined into a space of memory and cannot exit out of that space, so that they can't do any buffer overruns to find information on the system that's not allowed. In addition to AppArmor, we're glad to report that as far as SUSE Linux is concerned, we support both, right? We allow you to use SE Linux, and that's back in SLE 12 too. That's a great thing. Some governments require it, and so having those kinds of choices are something that we value in open source. So some of the tools that you can use to do this, you've got the Security Center that we were talking about. You've got AppArmor Profile Generator that helps you to manage to create those profiles for all of your applications that are running. You've got the integrity of the files in the system. You've got Nmap to look at all the ports, and some different kinds of scanners that we'll look at. There are all sorts of scanners that are available. I'm kind of partial to OpenSCAP, but there are other things that you may choose to use. Monitoring your system is important. Things like Akinga or Nagios, and maybe even Ganglia, which happens to be my handle. Syslog monitoring like Logwatch, vulnerability like OpenVAS or Tripwire, and always configuration management is something very helpful to consider. Tools like SUSE Manager or now the new SUSE Machinery thing also helps to ensure that you are getting profiles of what it is that's running and what is not, getting profiles of what's going on, and ensuring that only those things are happening on the server that you want to have happening. Whew, man, I talk fast. I hope this has been helpful to you. Are there any questions that you may have? Bron.
The next step that's not on there is reboot your server and make sure it's the same after a reboot, because otherwise you don't know that it will be.
Excellent. So comparing between reboots, that you've got the right set of services running now, and then every time you reboot, is it going to have the same reproducible set of services running on it, processes running? Excellent recommendation. Thanks, Ron. Others? Daniel.
So if you want memory protection, I can just recommend patching your kernel with PAX. And if you want role-based access control, you can even use GR security, which is really, really awesome. And it's being well maintained as far as I can tell.
Good. Great recommendations. Thank you. Other thoughts or questions? Up here in front.
You said something about SystemV providing security. So what does it provide for extra security for services?
So that may be a very long discussion, but I will tell you the most important feature of that. The most critical thing, the best thing that we buy from that is syslog. You now have a binary, not encrypted in that sense, but now an untamperable syslog with journal control instead of the regular text file varlog messages. That's the very best thing that we get out of that init process that now can trap all of that and keep that in its own unalterable repository without just spooling it off to the file system. Is that what you were going to say, Dereks? Dereks is going to make another comment about SystemD.
Two more things I would mention is you can enable syscall filters. So even if your program doesn't support it like BSFTP does, you can say after starting only Woo syscall should be allowed. So if you have a daemon that doesn't need exec, you can get rid of that exec call, and that makes most shellcodes like.
Great powerful capability that we
And
didn't
you
have
can
before.
assign AppArmor profiles as Linux profiles for your certain service. So you can have, for example, if you have instance services with that @ sign, you can say Redis for this service can only access its own database and not the database for the second Redis service.
Fantastic. I didn't think of that. That's a good one too. Good. Any other thoughts? Well, thank you for enduring my fast talking, trying to get through a lot of material in a short amount of time. Appreciate you being here. And may you have hardened and secured systems in your environment. Thanks.